In this video, we are going to do operations on complex numbers. But before we move on with operations, I would like to kind of refresh your memory and introduce a new format of complex numbers. Complex numbers can be represented in algebraic form, which is z is equal x plus iy. This is algebraic form. Okay. The next form is trigonometric form for complex numbers. This is z is equal r times cosine theta plus I sine theta. Excuse me. So this is trigonometric form. Where r is a radius, theta is an angle. Okay, and the form that I haven't introduced you, that is complex number in exponential notation, and that is z complex number, confused with statistics. Z complex number is equal r times e to power I theta. This is exponential form. Okay, and in the trigonometric form and exponential form, our r radius is equal absolute value of z complex number, and it is equal square root of x squared plus. Using Euler formula, we can write down z is equal r times cosine theta plus I sine theta, and that is equal r times e to power I theta. Okay, why is that? Because based on Euler formula, e to power, based on Euler formula, e to power I theta is equal cosine theta plus I sine theta. Okay, where e is the exponent, I is the imaginary unit. So for the complex number z equal x plus I y, the following can be performed: e to power x plus I y, and it's equal e to power x times e to power I y. And we can use this equation only and only when we have e to power z complex number. Okay, so in the case when z is a real number, which means imaginary number is 0, which means if z is equal x plus 0I, then we are getting e to power z, complex number, is equal e to power x plus 0I, and we are getting e to power x times e to power 0, and it's equal e to power x. Now, if z is purely imaginary number, so purely imaginary number, then e to power z is equal e to power 0 plus I y, which is equal e to power 0 times e to power I y. And the answer is e to power I y. So, using Euler formula, we get e to power z is equal e to power x times e to power iy, and it's equal e to power x times cosine y plus I sine y. So what did we get here? This is our e to power x, and this is e to power iy is equal cosine y plus I sine y. Here is based on this formula. Let's solve some example. So write a complex number z equal to I exponentially. Okay, we know that z, complex number z, is equal x plus I y. So x is a, let me write here, x is a real portion, real number of z, complex number, and which is equal, in this case, 0, right? Because we have only 2I. And y is an imaginary portion of z, which is equal 2 in this case, because we have z is equal to y, to I. Find the modulus and argument. Modulus we call the radius r, and argument is going to be our angle, which means we need to find r and theta, radius and the angle. Okay, we know that r is equal square root x squared plus y squared, right? This is how trigonometric form is connected to form of x plus I theta, I y, algebraic form. Okay, and that is equal square root, our x is 0, 0 squared, our y is 2, 2 squared, and result we get 2. Okay, theta we call argument of z, complex number z, which is going to be equal arc tangent y over x. Just to refresh your memory real quick, if we have, this is our theta, for example, so tangent theta, okay, let me put this one theta because I don't want to put y instead of x. 1 second. Let's say this is our theta. That's what I was saying. This is y, this is x, because vertical always y, horizontal is x. I don't want to change it now. So tangent theta is always equal opposite leg over adjacent leg, right? So from here, theta is going to be arctangent. Arctangent is inverse, okay? Arctangent y over x. Now, if I write down tangent like this or tangent, it's the same thing, okay? Don't get confused. If in one place I put TG, in another place TAN. So one is European, one is US form, so it's not a big deal. All right, so theta is equal, it's an argument of complex number z, and it's equal arctangent y over x, which is equal, let me clean this, drafting, and this is equal arctangent. Since since it's going to be y is equal to and x is equal 0, right? We are getting arctangent of infinity, because division by 0 gives you infinity. And tangent of how many degrees is infinities? Half a pi. Why? Because on the graph, this is your half a pi. This is your negative half a pi. If you open in pre-calculus, I have gone in details about every single trig function. So you will see this is the format of tangent. And as you can see, at the point of half a pi, it never touch it because half a pi is an asymptote. So it's running to infinity. That's why arctangent of infinity is equal half a pi. Negative half a pi also actually at asymptote. So arctangent negative infinity is going to be equal negative half a pi. Okay. So therefore, the exponential form from here, we can write down that z complex number is equal r e to power I theta, and that is equal to I to power pi over 2I. Okay? Okie dokie. And this is going to be our answer. Next example. Write a complex number z is equal 4 minus 3I exponentially. Okay? All right. Let's use the formula that represent the modulus of complex number, which is r. It's going to be equal x squared plus y squared. In this case, we will get 4 squared plus negative 3 squared, and that is equal 5. Okay, the argument theta is equal arctangent, and it's going to be y over x, right? And our y is going to be negative 3. Our x is 4. 1 second. Right? So from here, hold on, let me squeeze in, it has to be arctangent. Arctangent negative 3 over 4. Negative 3 is a coefficient of imaginary number, and 4 is a real portion of imaginary number. So since I have here negative 3, I can take out, it's going to be negative arctangent 3/4. Okay, therefore the exponential form of complex number z is going to be equal r times e to power I theta, and that is equal 5 times e to power negative arctangent 3/4 times y. Okay, and this is going to be our answer. Okay, so let me solve another one. Complex number. For complex number in exponential form, z is equal to e to power pi over 3i. Find its algebraic form. So now we are going backwards from exponential form. We are going to algebraic form. Okay, so using Euler formula, we can write down z is equal to e to power pi over 3 I is equal twice, this is r, right? And here we have cosine pi over 3 plus I sine pi over 3, right? Because z, we know our complex number z is equal r times cosine theta plus I sine theta. Let me make it too thick. All right. 1 second. Ooh, what was that about? Let's be careful. Okay. Can't clean this one. Very good. So, and from here, continue solving. We are going to have it's equal twice cosine pi over 3 is 1/2 plus I times sine pi over 3 is square root 3 over 2. There is a table. In the word situation, you can open your calculator. And this is equal 1 plus square root I square root 3. I'll put that way. Okay, and this is going to be our answer. So answer is in the algebraic form, z is equal 1 plus I square root 3. Okay, so next video I will represent operations over complex numbers.